Hi, welcome back to Pacifica Science and week number 4 of the 2020-2021 school year. A little bit about where we've been and where we're going. We've touched on a little bit of everything last week, a little bit on the Big Bang, the periodic table, how to graph variables, X and Y, a little bit on current events. We've even talked a little bit about the weather and lightning. The reason is, of course, we're trying to give a little bit of an overview of the class. The focus of this class is life science. We're talking a lot about viruses, cells, the diversity of life on Earth, and one of the most important things is to give a little bit of background. Where do all the chemicals of life come from? How do we get to where we are? That's why I like to talk about where we've been and where we're going so you know what to expect this week. And as we move forward from week 4, we're going to get into a little bit more detail now on life on Earth over the last, 3.5 billion years. While this isn't a chemistry course, the study of life is really the study of chemistry. We went back all the way to the Big Bang, all the way to the very beginning, because if you look at the chemicals that make life possible, you've got hydrogen starting off at the beginning of our universe, almost 14 billion years ago, coming together in stars, stars exploding and making heavier, bigger elements. And those heavier, bigger elements get together and make all of the complex molecules that make life possible. So we have to have a little bit of a grounding in chemistry, which is why I want to tell you a little bit about the periodic table, a little bit about the history of life in the universe, and a little bit about, hey, where did all the chemicals that make life possible come from? Here's one quick example of how understanding a little bit of chemistry is so important to not only just succeeding in this course, but really enjoying and understanding and being able to function in a modern society. We have to have a little bit of understanding of chemistry and a deep understanding of science if we're going to be able to really grasp what's going on in our modern society. If you look at, for example, chemical engineering, the little picture down in the bottom right hand corner there is a bunch of carbons stuck to a bunch of hydrogens, and you look at the oxygen coming up out of the ocean. The following example is straight out of a walk today on the beach here in Pacifica. And if you look at our ocean out there, we live next to the beautiful Pacific Ocean. Plankton in the Pacific Ocean and all around the world make about half of the oxygen that we breathe. Now, those of us who are into breathing oxygen would be very interested to know that there are some things threatening the plankton and our oceans, which we live right next to. And understanding what's going on so we can make good decisions for our future have to involve an understanding of chemistry. One of the things that we definitely want to do over the course of the next semester is make sure that everything we do hits, of course, the NGSS standards, but at the same time is local and it matters to us. Check out this picture right here. You've got a plastic spoon on the beach at Lindamar this morning. This right here was taken September 13th, Sunday morning, about 10 a.m. And I took this picture, and of course, I cleaned up the plastic spoon. It wasn't a staged picture. I was walking along the beach, and there's plastic garbage all over the beach. You might be interested to know that chemical engineers have made that plastic. Now, plastic makes our lives convenient and easy. Think about every single day we use plastic. It would be very difficult to go through a day without using everything from a Ziploc bag to a plastic spoon to something made of plastic. But if you look at the plastic that's in this picture right now, it's causing a lot of problems in our environment. It's problems that science has created because we've turned science into to engineering, but science can also solve these problems. That's why we're in class. If we're just doing the science class to remember a bunch of facts and figures, to put them on a test, and then move on and pass our test and say, hey, I got my A in the class, now that's not good enough. We have to be using the science, we have to be understanding the science so that we can be better students, but better citizens, really better able to make decisions about our future. This picture was taken just down the beach, maybe about 50 yards from that plastic spoon, and it was, unfortunately, of a dead bird. Now, certainly birds, in this case it was a grebe, birds die of natural causes all the time, but about half the time along California beaches, when you find birds that are dead along the beach, it's because they have, unfortunately, a gullet full of plastic. They're mistaking plastic for food, and the ocean, being downhill from everywhere, is being filled up with plastic garbage. Chemical engineering has made this amazing substance. It's a bunch of carbon. Hey, it's just a type of atom from the periodic table. It's a bunch of carbon that's double bonded. That just means it's stuck together very, very well. It's a bunch of double bonded carbon that sticks together very well. We can mold it into all kinds of shapes. As a matter of fact, the word plastic has to do with being able to mold it in all kinds of different shapes. It's great. It's convenient. We use it all the time. But at the same time, all the plastic that's not being recycled, and by the way, about 90% of plastic does not get recycled. All that plastic that isn't getting recycled goes into that beautiful ocean that we happen to live next to. And if we're taking a science class, it is not just about understanding, okay, can I pass this for the test? Can I remember the vocabulary terms for the test? That's not good enough. We have to be able to put the science to use. We have to be able to say, okay, how can we take the science that we've learned in this class and do something useful with it? Right now, one of the things that we're going to be talking about in this class throughout the year, trimester 1, 2, and 3, is how our understanding of chemicals and engineering relates to our environment as a whole. So in science, when we talk about things like, for example, the universe, starting from a little point where all matter was condensed into one incredibly dense spot, and then it's been expanding for 14 billion years. How do we know that? I mean, yeah, Mr. Forbes is 53 years old. Yeah, he's got gray hair and he's kind of old, but wait a second. He's not 14 billion years old. Why should I take his word for it that we know the age of the universe? Well, check out that little diagram that's right there that says distance versus velocity. There was a gentleman by the name of Edwin Hubble, and he took measurements of the speed of galaxies that were rushing away from us. And every time he saw a galaxy, he realized that the further the galaxy was away from us, the faster it was moving. Now, if you take that information, you put it backward in time, you could kind of figure out when everything was all together in one point. This gave us a rough idea of the age of our universe. That is stunningly amazing that you are part of a generation that now knows the age of our universe, which is just a little bit shy of 14 billion years. That's part of the reason why I was asking you to do the observation of the moon. If you look at the moon over successive nights, it's been a little bit weird here with the red skies lately, but you can see that there are patterns. It's predictable. That's the beauty of science. You can start looking at things around you and you can see that nature and the world is predictable. We're not victims of random chance so much as you can see patterns emerging. That's one of the reasons that we have this science class right now. So as we move into week 4, I want you to think about bringing it all together. When you look at the tiniest baby, as soon as you can start to talk and think and talk with other people, you start asking questions. Why is the sky blue? Why are trees green? Things like that. And the wonderful thing about science, it's a way of understanding our world. It's a way of understanding our universe. One of the things that I've tried to stress over the first couple of weeks and give you examples of is that math is the language of science. If you don't speak the same language as someone else, you do speak the same language if you know mathematics. If you check out the math that we've done so far, just a very, very simple graphing of dependent versus independent variables on an x and y axis, that right there is already giving you one of the tools that's critical to understanding the science that we're doing. So I'm looking forward to checking out in week 4 with you 2 of the most important laws in science, conservation laws, the conservation of mass and the conservation of energy. Those 2 laws right there give us information on understanding not only the things that we know about our universe, but it helps us understand our modern world and going forward, how you can understand the chemistry and the physics that you'll be doing in 8th grade in high school. Take care. Can't wait to see you in class and online. Bye-bye.